So I'm Olivier Mielo. I'm coming from France, Sofia Antipolis, Europe. So I'm very pleased to be here today and share with you the experience I have and we had around the SystemC platform. So in fact 2 years ago we started to prototype a SystemC platform in order to validate UMTS Layer 1 protocol stack. So a few words on the agenda. So first I will expose to you the challenge we faced, the prototyping approaches that were offered to us. A few words on SystemC, then why we choose CoWare and what the ESL are offering. I will then show you the platform we created. So basically it was a platform, dual-core platform. And some word also on the organization of the project. I mean, what were the deliverables to our customers? What were the inputs we need to set up this project correctly, and so on. Then I will show you how to create a simple functional unit, which is the radio interface unit, and you will see that we make a connection between the virtual platform and a reference tester, and this allowed us to make a dynamic test, in fact. And finally, the project benefits. So the challenges. So in fact, when this project started, the idea was to create a real IC. And we moved from an hardware-oriented architecture to a more software-centric solution. So why that? In fact, first, because as you can imagine, we could have more flexibility using a software approach, and so have more granularity to the features offered to our customers. And also because we introduced a new component, a new core in our design that is the EVP. So EVP is the embedded vector processor. And so in fact this core was designed by NatLab, which is a research laboratory located in Netherlands. And those guys looked to the 3G in advance and say, okay, we see that the most common algorithm that are needed are the spreading, the scrambling, and all these kind of things that you need to do to address the wideband CDMA. And so they say, okay, we will develop a dedicated processor core for you. And at this time, it was the first time we introduced this core in our design, and so this was a major impact in I mean a major modification, and so it was the first big challenge. So as I just told you, the idea was also to in fact create a layer 1 protocol for HS6PA, and to be able to continue to run the layer 1 existing software for the release 99. Also the idea, this is why we connected a reference tester to the platform, was to go to field test, let's say, as soon as possible, and as ever be on the market as soon as possible to answer our customers' requirements and needs. So just to mention that point, which is really important. In fact, as you probably know, the layer 1 release 99 stack is quite complex. You have to address a lot of use cases, and so I don't know if you are really familiar with that, but if you have a look or had a look to the 25 211 series and 212, you know that there are a lot of use cases to manage. I mean, you have many physical channels with slots formats. You will have the transport channel layer 1 mapping to these physical channels, with also a lot of combination and all the throughput based either on the TFCI decoding or on the blind transfer format detection and so on. And we also have to support Viterbi encoding, decoding, and turbo encoding, decoding. And so this is why we really need to make a prototype in order to reduce the risk of these changes. So what could be done? In fact, as you know, yeah, at least three solutions. So the FPGA prototyping. So this is really helpful because it's fast. You can target all your design on that. But in the case the design is complex and you need more than one FPGA, then you start to run into troubles, and it's not so easy to do. When the architecture is still changing and under construction, you will have to go in a loop with a new netlist generation each time you change something, and also you don't have the full visibility on your system. Last point is that in case you want to do multi-core debugging without breaking the real time, it's impossible, in fact. Second solution would have been to develop our own proprietary solution, let's say. So in this case, first you need to be sure that the instruction set simulator is available for all the cores in the system. And with this new EVP core, it was not the case. I mean, we had an ISS, but we did not want to spend too much time to connect it to the environment. And so this is why, for example, this core creation was outsourced to CoWare, and we got from them a fast model of this EVP. Again, also, as you can imagine, you will have to define the interfaces between your IPs, and then if you go then from pure functional verification to something more accurate, it's quite difficult to get interesting results on exchanges on the bus and things like that. And so the estimation you have with your own models is not perfect. Finally, again, if you have a platform with more than one core, and it was the case for us with this dual core platform, you have to create by yourself some instrumentation, and we did not want to do that. So basically we decided to use a virtual platform based on the CoWare solution. And this platform was used to first validate the functional requirements, so get the bit trueness of the IPs and the code in the system, check the memory consumptions, and also some concurrency aspects, be sure that the interrupt were triggered at the right time to run the protocol stack within this time slot, and the idea was also to maybe run the layer 2 and layer 3 on top of layer 1. So that was the last item. So the SystemC, so I'm sure you know SystemC. So it's a standard. It is open source. Basically, it's a C++ library that you have to use, and this is the standard we have today is the TLM 2.0. At the time we started the project, it was based on TLM 1, but it does not really matter, in fact. So basically, you have a transport function that allows you to make transaction exchanges between IP, and you know that you can use that to do embedded software development, but also some architecture exploration and go to the system verification. And for more information, you have the systemc.org website.